Hi guys, welcome again. This is the third video of the series Quant interview questions. And today we are going to discuss difficult questions. So basically some hard problems that has been asked previously by quant firm. Probably I think we are going to discuss four questions today, out of which one will be on easier side and the other three are, you can say that, on the harder side. Okay. I hope you have gone through quant interview questions one and two that have been an amazing series, and I will continue this series. Please drop your suggestion in the comment section, and let's start discussing questions. So this is the first problem of the series, which is easy according to me. So you start investing in the stock market and notice a stock priced at rupees 1000. Every minute the price can either increase by one or decrease by one, each with equal probability. What is the probability that the price will reach 1004 before it drops to 997? Okay. It's a boundary. We can consider that 1997 and 1004 are boundaries, and somewhere here we have 1000, right? Okay. And if you notice, every minute the price can either increase by one or decrease by one. So it's kind of a random walk, right? So there are multiple ways to solve this problem. So 1000, and then either it will become 999 or it will become 1001 or it will become 998, 1000, and then 1002, right? And so on. One thing you should notice that at any stage, the expected value of x, right, at any time step would be 1000 only. You can check it, right? So 999 with a probability of half and 1001 with a probability of half. So it would lead to an expectation of 1000, right? Excuse me. Similarly, at any other time step, you can notice that the expected value will be 1000. Okay. So what I can do is I can use the optional stopping theorem. So at the end, so either we are going to stop when the stock prices reaches 997, or we are going to stop when uh, we reach 1004. So maybe we can denote that maybe we are going to stop when it reaches 1004 with a probability of p. Otherwise, with a probability of 1 minus p, we will be going to stop when we reach 997, right? So these are the only two possible scenarios when we will be stopping ourselves, right? Either we reach 997 or we reach 1004. We are saying that when we reach 1004, we'll stop with and the probability that we will stop when we reach 1004 is p, or the probability that we stop when we reach 997 is 1 minus p. And what will be the expectation when we stop, right? Expectation at any time step x when we stop would be 1004 into p plus 997 into 1 minus p, right? This is a probability that when we will be stopping, right? And this probability, since it is random walk, should be equal to 1000, right? 1004 into p plus 997 into 1 minus. From here, you can calculate what will be p, right? By the way, this is kind of a standard random walk problem. So you can relate it with multiple problems that you have already seen, probably like table kind of problem. So this is a table, right? And there are two sides to it, and there is one insect from over here, and then these insects either go one step right or one step left, right, with with equal probability. So the question is, what is the probability that the ant will or the insect will fall on A side or B side, right? So the problem is quite standard, and let us say this distance is x and this distance is y. Okay, so it's kind of inversely proportional kind of thing. So the probability that the ant will fall on the B side would be x divided by x plus y, and the probability that the ant will fall or the insect will fall on the A side will be y divided by x plus y. Similarly, in this case, you will see that the probability that the price will reach 1004 before it reaches 997 will be, since this distance is 3 and this distance is 4, so this will be 3 divided by 7. You can match this particular answer. So let's do it and see whether we are getting that or not. So 1004p minus 997p plus 997, right? So it would be 3 on this side, and then on the denominator we will be having 7 equal to p. So you can see that the answer is indeed 3 by 7, right? Let us do the second question. This is a bit on harder side. So suppose players A and B are playing a game with a fair coin. Fair coins. To begin the game, A and B both flip their coins simultaneously. If A and B both get heads, the game ends. Okay. So if so, A and B are tossing the coin simultaneously. So if they both get head, okay. So if they both get head, the game ends, right? If A and B both, if both get tails, right, they flip again simultaneously until they get tails, right? So if they both get tails, then they will be flipping simultaneously again and again until they both get heads. Now, if one of them get heads, right, if one of them get uh, head and one of them get tails, then what they do is that the one who got head will be, so this guy A will be tossing the coin again and again until he gets T. And once he gets T, he will be, they both A and B will be tossing simultaneously until they get head and head again. Similarly, uh, over here, this guy B has got heads, right? So he will again uh, toss the coin until he get a T, right? And once they both, so now they both have a T, so they will again start and flipping the coin simultaneously. Okay, until they both get head together. So now the question is asking what is the expected number of flips until the game ends, right? Obviously, this will be counted as two flips, right? H and H. Similarly, this two again will be counted two flips, but of course, this is not the expected number of flips until the game ends. Obviously, here the number of flip is two, but this is not the expected number, right? Now the question is quite interesting and a bit tricky, but again, it's on the easier side if you get the intuition to this problem. Okay, so before I start the solution, I think I would suggest you to start thinking about the approach yourself, because this is kind of a problem on the easier side rather than on harder side. So once you get the intuition, you will be quite happy if you solve this problem. Okay, so let us do this way. So let us say that E is the expected number of flips until the game ends, right? So now E will be, so if you both, if you get head in the first toss itself, so A and B both got head, so the number of flips that was required was two only, right? And the probability of it to happen is 1 by 4. Now if both of them get tails, so they have wasted, so the probability of which is 1 by 4. And now if both of them has got tail, so what they will do is, obviously they have wasted two toss, and now they will again start flipping the coin simultaneously until they get, uh, they both get head, right? So since they have already got TT, right, this TT, this is the two toss that they have wasted. Now they can freshly start from here, right? And then they will get the two heads simultaneously in H flips, right? Because this is the because E is the expected number of flips required to get two head if you start from nothing, right? And so obviously they will start again from here, and which is, so if they start again from here, E is the expected number of flips required to get a flip. Now, when they get H and T and T and H, right, the problem becomes interesting, obviously. So what they will do in this case is that this guy B is now waiting for A to get a T. Once A gets a T, then they will again start, right? So the problem is about, so this, the probability of it to happen is 1 by 4 into, now what they will do is that first A will get a T, right? A has to get a T. Now expected number of tosses for A to get a T is 2. You can do it yourself. This is kind of an easier problem, right? Now once A get a T, so this, they both get a T. From there, how many steps it take if they both are on TT? From there, you already know it takes 2 plus E steps, right? For them to get HS consecutively, not consecutively, simultaneously. Okay, and similarly, this will happen for TNH as well. So 1 by 4 into 2 plus 2 plus E. right? If you solve this, the answer that you are supposed to get is 12 for this particular question. Okay. Let me know in the comment section if you uh, have any doubt related to this particular question. Okay, this question is going to be a bit interesting and kind of it does not matter whether you figure out the final answer to this particular question. What's important is that you at least understand the intuition behind this particular problem, or at least to understand the approach that they are willing to look for you into you, right? So the problem is that you are choosing x and y at random from 0 to 1. Okay, what is the probability that y divided by x is closer to an even number than an odd number, right? Okay, so uh, what this problem asks is kind of what is the probability that y by x is closer to an even number than an odd number? So for example, if y by x is 0.7, right, then it is closer to an odd number, right? But if your y by x is 0.3, it is closer to 0. So it's closer to an even number, right? Okay. So let's do this way. Uh, Try to let's first make sense it geometrically. Okay. This is your x-axis, and this one is y-axis. So we have 0 to 1 over here and 0 to 1 over here. And let us make square. So this is in a square. I am not make it correctly, but of course you know that this is square of dimension 1 into 1, right? So you are choosing a particular number in between this region, right? Okay. I hope that makes sense. Now starting with the easier, so maybe you can divide it into some set. So if I write it this way, uh, try to see like this. Okay. So this is the number. Let us say this is 0.5. Okay. So the equation for this particular line would be y divided by x equal to y is 0.5 and x is 1, right? So the equation for this particular line is y divided by x equal to 0.5 divided by 1. Okay. So now you can notice that any point that lies between this particular line, right, below this particular line, will be closer to 0. So you see that let us choose this particular number, right? What would this be? This be, for example, y over here, let's say is 0.3 and x is 1. So it would be 0.3 and it is closer to 0. Similarly, if you choose this particular number, right, a number over here, the x would y value would obviously be somewhere lesser than 0.5. So let's say it is 0.3, right? And x value somewhere would be let's say 0.5, right? So you can again check that it's just a minute. So any number that lies below this line, right, within this region, will be closer to 0. Any number, any point x by y below y by x equal to 0.5 will be such that will be such that y by x will be closer to 0, right? Any point in between this particular region. Okay. So just notice that This region is that region. So 0. You might be probably be wondering about the example 0.3 divided by 0.5, but that lies outside this particular point. Okay. So at 0.5, so let me tell you, if y by x is 0.5 y1, right? So probably if you're looking at white point, you are having 0.3, right? So if you put y equal to 0.3, right, then it would be happening at x equal to 3 by 5, right? Sorry, x equal to 3 by 5, it will be happening. And that, so any ratio, right? So any point in between these will be closer to 0.5, okay? So you can check it geometrically, okay? And one interesting thing to note is that this is the line y by x equal to 0.5, okay? Or this is the line that is, so this is the same line 0 by y by x is between 0.5, okay? This, in between any this point will be closer to 0. What is the area of this line? What is the area of this triangle? It will be 1. So 1 by 2, which is the base, into 1 into 0.5, it will be 1 by 4, right? Now let us consider a different triangle, right? And the triangle would be, so for now we considered 0, y by x is less greater than 0 and lesser than 0.5. So let us consider 0.5 is greater than y by x into greater than 5. You can check similarly that this y by x line, okay, will be closer to 1 than 0. And so it is closer to an odd number, right? So this particular triangle that you will be considering, right, where the ratio between y by x is between 0.5 and 1 to 5, it will be closer to 1 than 0. Okay. So this is 0.5. So 0. So y is, so what is this triangle? Y equal to 0.5 lesser than y by x. This triangle is y is greater than 0.5x. This is y is greater than 0.5x, right? So this area lies between y is greater than 0.5x and y is lesser than 1.5x, right? Where would y is greater than 1.5x lying? You probably, right? This will probably be lying between which region? Uh, so this is 0.5, this is 1, so it will lie somewhere here, right? So you see that any point in between this will be closer to 1. And alternatively, 1.5 is less than 1 by 6 is 2.5. This triangle will be closer to 2, an even number, right? So what you have to do is you have to, between square one area, you want to see that any point that lies between this line, that is 0.0 to 0.5, 1.5 to 2.5, right? And so on. And then what would be the next? 3.5 to 4.5. So all these points that lie between uh, these particular triangles, right, will be between whatever you say, whatever between, so which will be close to even numbers, right? Right. So please think about it and let me know if you don't understand with this particular thing, right? think about it. Pause for a while and think about it. So if and then the next would be 5.5 to 6.5. This will also be closer to even number. Any point in between these two will be closer to even number. Okay. Now, tell me one thing. What will be the area in between the square region, right, of something that lies between these two particular triangle? Okay. So if you see over here, right, is 1.0.5, and then it is what is this line? This line is y by x is lesser than 1.5, right? This is 1.5. So if you see this particular area, right? So this is this point. This particular point is nothing but y is greater than 1.5x. So y is 1 over here. If y is 1 at this point, then your x would be 1 by 1.5, right? 1 by 1.5. Okay. So this particular triangle will lie between x from x equal to 1 by 1.5 to 1 1 by 2.5 to 1 by 1.5, right? And similarly this will lie between triangles of x from x equal to 1 by 4.5 to 1 by 3.5. Okay. So now tell me what is the area of this particular triangle? Since height is obviously 1, so the area of this particular triangle would be 1 by 2 into 1 by 2.5 minus 1 by 3.5 into 1. Right? Area of this triangle would be 1 by 2 into 1 by 4.5 minus 1 by 3.5, right? And so on. Finally, you can write it something like, so let me write it here at last. Okay. So finally, the total, so obviously the total area is 1. And now you have to count that area which lies for the points area enclosed by the points that are closer to even number, right? For which y by x is closer to even number. So it will be 1 by 4 plus 1 by 2 into this number is 1 by 1.5. So this number, wait, 2.5, 1 by, wait. So this would be 1.5, right? I wrote for this, right? And for this. So for this, so for this one, area of this particular region would be 1 by 1.5 minus 1 by 2.5 plus half 1 by from 3.5 minus 1 by 4.5 and so on, right? 1 by 4 plus half, so we can write it as 2 by 3, and then it would be 2 by 5, right? Plus half, it would be 2 by 7 minus 2 by 9 and so on. So it would be 1 by 4 plus 1 by 3 minus 1 by 5 plus 1 by 7 minus 1 by 9 and so on, right? And you already know that you can probably write it as 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus 1 by 9 and so on, right? And so basically you should have a minus sign over here. 1 by 4, and you should have a minus sign over here. And since we are adding minus 1, you should add plus 1. So it would be 1 plus 1 by 4. And you already know the value of this is something nothing but pi by 4. So the answer to this question would be 5 by 4 minus pi by 4. So this was just nothing, but you just have to see that between these two lines, right? So for these two triangles that you are considering, between these, they are closer to odd number. And if you are considering this region, all the points that lie between this region are closer to even number, right? And then you have to calculate the area of this region, this region, this region, and so on. So infinite number of regions, right? And then you just have to add those areas. So this was all about this particular problem. And now let's talk about this problem. Let us say, so let's discuss the fourth and final question of today. This is again going to be a question on the tougher side. Okay. So this particular question, if you look at it, it says that A keeps tossing a fair coin until he gets two consecutive heads, right? Define X to be the number of tosses required for the process. B keeps tossing another fair coin until he gets three consecutive heads, right? Define Y to be the number of tosses required for this process. Calculate P is greater than X. So most of the people they get confused in this particular question. They say that uh, three consecutive head will only come when we get two consecutive head, right? So the probability that the number of tosses required for two consecutive head will be greater than three consecutive head will be 0. Is it? Do you think so? If yes, then again read the problem again. A and B are tossing the coin separately. It may happen that A has not got two consecutive heads before B gets three consecutive. So the events are obviously independent, right? So the probability can have a significant number. It will not be 0, of course. Okay. So let's start doing this particular problem. Obviously, the problem will be done by writing in terms of state that they are currently at. So we have two people, A and B. Let us just say that M and N are the number of consecutive heads that they are currently at. So for example, they can be at 0, 0, 1, 0. That means A is at one head and B is at currently not having any head. Then 2, 1, or basically 1, 2, and so on, right? So Sm comma n, let us say Smn comma n denotes the probability that A gets two consecutive heads. Later than B gets three consecutive heads, right? This is what we have to find. Given that the current head strike of A is M and for B it is N. So A is currently at M heads and B is currently at N heads. So basically you have to find what is S00. So this is the probability that A gets two consecutive heads later than B gets three consecutive heads, given that the current head strike of A is 0 and current strike of B is 0. So you have to find this particular number, right? So we'll be using some recurrence relation to solve this particular problem. But before that, let us just look at the boundary condition that we have, right? That is more important. So Sm comma N, right? So the boundary condition that we will be having is that Sm comma N will be 1 for M is lesser than 2 and N is greater than 3. So if N has already got three consecutive head, but M has not got two consecutive head, right? then obviously it will be 1. The probability that A will get 2 consecutive head later then B will obviously be 1. Otherwise it will be 0. When it will be 0? It will be 0 when M is greater than or equal to 2. So M has already got 2 consecutive head and N is lesser than 3. So in this particular cases, so these are the boundary conditions that we have. So these boundary conditions will be very much helpful to solve this particular problem. So if I again repeat the boundary condition, the first boundary condition says that A has already, sorry, the first boundary condition says that B has already got 3 consecutive head, but A has not got 2 consecutive head yet. And the reverse of that is true for the second boundary condition, right? Now let us write the recurrence relation that we have, right? So if you look at the recurrence relation, how will it look like? So if you are at currently Mn, let us first write where you can go. Okay. So if you are at Mn, okay, if they both get heads, one extra head, so they will go to M plus 1, N plus 1. Okay. So they both have H has 8HH. If one of them gets a tail, right, then what will happen? It will be M plus 1 comma 0. If they both get tail, right, then they will again go back to 0 0. And if they got TNH, then it will be at 0 N plus 1. So these are the four possible situations they will be